Alright, let us review the whole method. Of course, I applied it on a particular example, but the method is general, and if you just review the logic of that example, then you will easily see why the method works, right? So if we have a non-homogeneous second-order differential equation, maybe even with non-constant coefficients. So as long as we know the general solution of the corresponding homogeneous differential equation, we are able to solve the non-homogeneous differential equation, right? Right. So first, we're going to look for a particular solution of the non-homogeneous equation in the form where it is a combination of two independent solutions of the homogeneous differential equation with coefficients that are functions of t. Right. So then, in the method of variation of parameters, we came up with two equations on u1, strictly speaking, on u1 prime and u2 prime. So the first of these equations is always going to be u1 prime times y1 plus u2 prime times y2, and it comes from a trig. And the second equation tells us that, let me write down the second equation. So the second equation is u1 prime times y1 prime plus u2 prime times y2 prime is our right hand side, g of t. Right, but these two equations together, if you think of them differently, then these two equations together, they are just a system of algebraic equations with unknowns u1 prime and u2 prime. But since it is a system of algebraic equations, you can easily solve it. But then when you solve the system by Cramer's rule, you will get a specific formula for u1 prime and u2 prime. So in order to recover the original u1 and u2, you will have to integrate. And then I have prepared the final answer for you. Now, and then whenever you need to apply the method of variation of parameters, you don't have to go through all the steps again. You can just apply the final formula. That's the final formula.